यस, लेट्स स्टार्ट विद द डेरिवेटिव एंड इंटीग्रेशन। उसका जो बेसिक कंसेप्ट है तो वो तो ऑलरेडी मुझे लगता है आपको क्लियर होगा, क्योंकि उसके अंदर जो रेगुलर के अंदर जो हमने पढ़ा है डेरिवेटिव के बारे में, तो वो तो नॉर्मल है, मतलब वो उसके अंदर सिर्फ फॉर्मूला बेस्ड है, सिर्फ फॉर्मूला तुमको लगाना है और उससे तुमको आंसर निकालना है। तो डेरिवेटिव जैसे ही अगर इक्वेशन दिया जाता है तो उसका फॉर्मूला लगा के हमको आंसर निकालना, इतना ही उसमें है। ठीक है, लेकिन अभी नीट और जेई के लेवल पे अगर हम देखेंगे तो डेरिवेटिव के अलग अलग एस्पेक्ट्स और अलग अलग रूल्स जो है वो हमको ध्यान में रखने होंगे, और उनको यूज करके ही हमको बड़े बड़े जो अलग अलग जो इक्वेशंस होते हैं तो वो हमको सॉल्व करने होते हैं। सो लेट अस सी सम रूल्स इन द डेरिवेटिव। ओके, सी, आई होप ऑल ऑफ यू कैन सी द स्क्रीन। ओके, सो लेट अस सी। तो बेसिकली सबसे पहली बात जो हम डिस्कस करेंगे तो वो है ये है कि डेरिवेटिव एक्चुअली होता क्या है। तो उसका तो आंसर हमको ऑलरेडी पता है, फिर भी एक बार रिपीट करते हैं कि डेरिवेटिव इज गोइंग टू बी द रेट ऑफ चेंज, बराबर है, रेट ऑफ चेंज ऑफ वन क्वांटिटी विथ रिस्पेक्ट टू अनदर वन इज कॉल्ड एज द डेरिवेटिव। ठीक है, उसको हम अगर हम कहते हैं कि रेट ऑफ चेंज ऑफ y विथ रिस्पेक्ट टू x, तो उसको हमेशा हम इस तरह से लिखते हैं dy बाय dx। आए समझ में ठीक से, dy by dx, dy by dx actually doesn't stand for ratio of dy and dx, but it stands for the limiting ratio of dy and dx। मतलब अगर हमने डेल्टा y और डेल्टा x इन दोनों का जो रेशियो है, तो उन दोनों का रेशियो का अगर हमने लिमिट निकाला as delta x tends to 0, then that limit turns out to be a constant number or fixed number. That is actually called as the derivative of y with respect to x. So accordingly, the terminology will change time to time. Because if we want to find out the rate of change of y with respect to x, then we can call it as dy by dx, no doubt. But if we want to find out the rate of change of s with respect to t, then we can call it as ds by dt. Okay, ds by dt का मतलब क्या हुआ, rate of change of s with respect to time t in this way. If you want to find out the derivative of or rate of change of velocity with respect to time, then it will stand for dv by dt. And if suppose we want to find out the derivative of suppose momentum or rate of change of momentum with respect to time, then it will stand for dp by dt and so on like that. So mostly क्या है ना कि रेट जब हम यूज करते हैं, रेट ये वर्ड जब यूज करते हैं तो मोस्टली वो टाइम के हिसाब से होता है, याद रखो ठीक से, टाइम के हिसाब से। बट कभी कभी जो रेट ऑफ चेंज विथ रिस्पेक्ट टू डिस्टेंस भी लिया जाता है, डिस्टेंस के हिसाब से भी रेट ऑफ चेंज लिया जाता है, उसको हमेशा हम ग्रेडियंट बोलते हैं। ग्रेडियंट, ये भी वर्ड याद रखो अच्छी तरह से। ग्रेडियंट मतलब क्या, जैसे फॉर एग्जांपल अगर हम देखेंगे तो वेलोसिटी ग्रेडियंट, तो वेलोसिटी ग्रेडियंट का मतलब क्या हुआ, तो वेलोसिटी ग्रेडियंट का मतलब है रेट ऑफ चेंज ऑफ वेलोसिटी विथ रिस्पेक्ट टू डिस्टेंस, जिसको हम dv by dx डिनोट करेंगे। तो अब यहाँ पे देखो इसमें यहाँ पे किधर भी टाइम नहीं है, टाइम है ही नहीं इसके इस इक्वेशन के अंदर, तो इसलिए ग्रेडियंट का मतलब क्या होता है, द रेट विथ रिस्पेक्ट टू डिस्टेंस, रिमेंबर। दूसरा आता है सपोज पोटेंशियल ग्रेडियंट। ठीक है, तो पोटेंशियल ग्रेडियंट इसका मतलब क्या हुआ, तो पोटेंशियल का रेट ऑफ चेंज बट नॉट विथ रिस्पेक्ट टू टाइम, but it should be with respect to distance, so it will be d capital V by dx. So this is going to be the potential gradient. In the same way here the temperature gradient, अगर सपोज टेम्परेचर जो है वो अगर डिस्टेंस के हिसाब से बदल रहा है तो ऐसे हालत में टेम्परेचर ग्रेडियंट becomes very important, and this temperature gradient will be denoted by d theta by dx in this way. दैट मीन्स इन शॉर्ट क्या है ना कि हम किसी भी क्वांटिटी का रेट ऑफ चेंज निकाल सकते हैं दूसरे किसी भी क्वांटिटी के हिसाब से। ठीक है, तो अभी इसमें कुछ रूल्स आ जाते हैं जो हमको यहाँ पे याद रखने हैं डेरिवेटिव के अंदर, ठीक है ना। सबसे पहले आता है चेन रूल, उसको हम बोल सकते हैं, ठीक है। डेरिवेटिव के अंदर सबसे पहला हम रूल डिस्कस करेंगे, दैट इज अबाउट द चेन रूल. व्हाट डू यू मीन बाय दिस चेन रूल? is suppose we have a quantity called suppose x, there is another quantity called y, और suppose in short हम ऐसा करेंगे, एक क्वांटिटी जो है वो y है और ये एक क्वांटिटी x है, और तीसरा एक क्वांटिटी हमारे पास है जिसको हम बोलेंगे सपोज t. ओके, t इस तरह से. तो अभी देखो यहाँ पे, ओके हम यहाँ पे चेन रूल देख रहे हैं. तो होता क्या है ना कि y डिपेंड्स ऑन x समहाउ, कैसे भी करके x के ऊपर y डिपेंड करता है. जैसे ही x चेंज होगा तो अकॉर्डिंगली वहां पे y चेंज होगा ऑटोमेटिकली, और x एक्चुअली इन टर्न डिपेंड्स ऑन t हियर. तो इसका मतलब देयर इज अ रिलेशनशिप बिटवीन दिस x t एंड x एंड y. तो मतलब t का जो वैल्यू है तो उसके ऊपर x का वैल्यू डिपेंड करता है, ठीक है, और x का जो वैल्यू है उसके ऊपर y का ये वैल्यू डिपेंड करता है. So when the value of t will be t here, value of x will be x, no doubt. But at that time, the value of y will be y. Okay. Now suppose that the value of t changes slightly. अगर t का जो वैल्यू है वो अगर चेंज हो जाता है और वो बन जाता है t प्लस डेल्टा t सपोज. ओके, देखो यहाँ पे t का वैल्यू क्या बन गया, t प्लस डेल्टा t बन गया. Immediately the value of x will also change and it will become x plus delta x. Okay, and automatically the value of y will also change and it will become actually y plus delta y. Okay, so here there are three variables y, x and t. In that y depends on t, sorry x, and x depends on t. So can't we say that y indirectly depends on t? Okay, now we can find out the rate of change of y with respect to x. Okay, that is called as dy by dx. Okay, dy by dx का मतलब क्या हुआ? It is called as the rate of change of y with respect to x. Okay, we can find it out. It is going to be actually the limit of delta y upon delta x, no doubt. And even we can also find out the rate of change of x with respect to t, because x depends on t directly. That's why we can find out the rate of change of x dx by dt. ये हम निकाल सकते हैं आराम से, इसको बोलते हैं dx by dt. ठीक है, this can also be found out. Okay, no doubt. But if suppose we want to find out the rate of change of y with respect to t, what we are going to do here? How will you find out the rate of change of y with respect to t? Because see, rate of change of y with respect to x is already there. Rate of change of x with respect to t is also already there, but we don't want that. We want dy by dt. तो देखो यहाँ पे dy by dt मतलब ये हमको निकालना क्या है, rate of change of y with respect to t हमको निकालना है, बराबर. So the method to work this out is just multiply these equations. ये जो इक्वेशन नंबर सपोज 1 दिया हुआ है और ये जो इक्वेशन सपोज 2 है, तो इन दोनों को अगर हम मल्टीप्लाई करेंगे तो क्या होगा, देखो. If you multiply 1 and 2, then we can get this as dy by dx multiplied by dx by dt. So that here we can get the rate of change of y with respect to t. In short क्या है ना कि जब फ्रैक्शनल चेंजेस जो है, जो फ्रैक्शनल चेंजेस जब हम कंसिडर करते हैं तो उस केस में क्या होता है कि ये dx और ये dx जो है वो एक तरह से ऐसा बोल सकते हैं कि कैंसिल हो जाता है, ठीक है, और उसकी वजह से हमको जो मिलता है तो सिंपली dy by dt मिल जाता है. तो here you can see that this dy by dt can be found out to be just the product of dy by dx and dx by dt as well. Okay, see here we'll see some examples of this. अभी इसके हम कुछ examples देखेंगे. देखो जैसे कि for example देखो अगर डिस्प्लेसमेंट जो है, सपोज तुमको पता है कि y is given to be root of x, okay, and suppose x itself is given to be, suppose sin x, okay, sin t, sorry, okay. How will you get the derivative of y with respect to t then? So in this case we have to differentiate this equation dy by dx and find out this dy by dx. How much it will be? It will be 1 upon 2 root x, no doubt. At the same time, differentiate this equation also. X को भी differentiate करो, so that we can get this dx by dt, which is actually going to be sin t. Sin t का derivative क्या बनता है with respect to t? तो वो बनता है cos of t, correct है? Yes. And then we'll be able to find out this dy by dx here. Sorry, dy by dt here. So dy by dt can actually be found out to be dy by dx into dx by dt, correct है? Where dy by dx happens to be, see it here, it is going to be actually 1 upon 2 root x, right? And that is to be multiplied with dx by dt, where dx by dt happens to be cos t, correct? So if we replace it by that here, then we can get the final answer. And even if we want, we can just put this value of x as sin t here. x का वैल्यू जो है ना sin t, तो वो अगर हम पे डाल देंगे तो हमको मिलेगा simply cos t upon 2 times of root of sin t. That's all. So देखो, this is going to be actually the derivative of y with respect to time t. Okay, this is one of the examples. Okay, second example. Let us see. Suppose that x is given to be 2t plus 5 and y is actually given to be x square. Okay, तो अभी देखो यहाँ पे x जो है वो t का फंक्शन है, t के ऊपर वो डिपेंड करता है, और y जो है वो x पे डिपेंड करता है. चेक करो ऐसा डायग्राम हो गया कि नहीं? ये t उसके ऊपर डिपेंड कर रहा है x और उसके ऊपर डिपेंड करता है y. जैसे ही t चेंज होगा तो सबसे पहले x चेंज होगा, और जैसे ही x चेंज होगा तो उसकी वजह से y चेंज होगा. सो जब t का नया वैल्यू आएगा तो वो x का नया वैल्यू बनाएगा, और x का नया वैल्यू जो है वो y का नया वैल्यू बनाएगा. तो अभी यहाँ पे हमको रेट ऑफ चेंज ऑफ y विथ रिस्पेक्ट टू t ढूंढ के निकालना है. यू हैव टू फाइंड आउट द dy by dt, whereas we can find out the rate of change of y with respect to x easily, and also the rate of change of x with respect to t can be found out easily. But the case here is that you have to find out the rate of change of y with respect to t. And how can we do that? Just differentiate this first. So we'll find out dx by dt here. What is dx by dt? It is actually going to be root of 2 times of t plus 5. So 2 as it is, and t का डेरिवेटिव क्या बनता है 1, plus 5 का डेरिवेटिव क्या बनता है 0, because it's constant. So that means we are going to get that dx by dt is actually going to be 2. Okay, and what about this dy by dx here? So dy by dx can be found out to be equal to 2x. That's simple. And since dy by dx is obtained, dy by dx by dt is also obtained, we can find out dy by dt by using the chain rule, which tells us that dy by dt is equal to dy by dx into dx by dt. करेक्ट है? जिससे हमको मिलता है dy by dx, which is going to be 2 here, sorry 2x here, and that is to be multiplied with dx by dt, which is actually 2 here. And if we replace the value of x, which is going to be 2t plus 5 here, then we can be able to get that this is going to be 4 times of 2t plus 5 as a final. So this is actually the value of dy by dt. Okay, so remember, this is the chain rule we can see here. Even we can extend this chain rule up to any number of variables. Instead of 3 variables, we can also have the 4 variables included here. For example, suppose that y is equal to u cube, okay, and u is equal to sine v, okay, and v is equal to x square, and x itself is suppose going to be 5t, okay. अब देखो यहाँ पे इसमें डायग्राम कैसे बनेगा, t के ऊपर डिपेंड करता है x, राइट, x के ऊपर डिपेंड करता है v, v के ऊपर डिपेंड करता है u, और u के ऊपर डिपेंड करता है v, y सॉरी। तो इसका मतलब t यहाँ पे है, फिर दूसरा उसके ऊपर डिपेंड करने वाला है x, उसके बाद आता है v, और उसके ऊपर डिपेंड कर रहा है u, और उसके ऊपर फिर डिपेंड करता है y। देखो ठीक से इस तरह से उनके बीच में रिलेशनशिप है। तो यहाँ पे पांच वेरिएबल्स है, देखो ठीक से, we have the 4 equations and 5 variables actually. We can find out dy by du easily. See here, dy by du can be found out. Even du by dv can also be found out easily. Even dv by dx can also be found out, and dx by dt can also be found out, okay. But what we want here is we have to find out dy by dt, okay. देखो dy by dt हमको निकालना है। How we can do that? See here, first of all we have to find out dy by du. What is dy by du? Can you get? u cube का डेरिवेटिव क्या बनता है? It's going to be 3u square, right? जो हमारा फॉर्मूला है x raised to n का, याद होगा सभी को। तो x raised to n का डेरिवेटिव क्या होता है? n times x raised to n minus 1. तो इससे हमको ये मिलता है 3 times of u square, no doubt. Then again, what we can get this du by dx, sorry, du by dv. Tell me fast. du by dv कितना आएगा बताओ? तो du by dv बनेगा हमारा sin v का डेरिवेटिव जो बनता है cos v, okay. Then v का डेरिवेटिव क्या आएगा? dv by dx क्या बन रहा है बताओ? तो देखो dv by dx it actually becomes 2x, बराबर, and from this equation we can get dx by dt. What is dx by dt here? It's going to be 5, simply 5, okay. Now if you want to find out dy by dt, then we can express it as dy by du into du by dv into dv by dx into dx by dt. This is the chain rule. देखो यहाँ पे we can also expect that this du will get cancelled, dv will get cancelled, dx will get cancelled, and we'll be left with dy by dt only, no doubt. But ऐसा कोई करने का नहीं, but we have expressed it in this way so that we can find out the rate of change of y with respect to t, okay. So dy by dt is actually going to be, yes, dy by du. How much it is? See here, it is going to be 3u square, right? So this is 3u square into du by dv. How much it is? See it here, it is cos v here. So replace it by that, cos v, into what is dv by dx? It is going to be 2x here. So just replace it by that and get this 2x here, and that is to be multiplied with this dx by dt, which is going to be 5 only. So this is 5 here. So if you multiply all these things together, then we get this 2 into 5 to be 10, and 10 multiplied by 3 actually becomes 30. So we can write this 30 here in the front into u square into cos v into x. That's it. Even we can take this x in the front so as to get this as 30 into x into u square into cos of v. If you want, we can also express this in terms of a single variable, that is t. How? See here, we can write this as 30 into x. What is x? See here, it is 5t, right? So we can just replace it by that. This is 5t into u square. What is u here? See it here, u is nothing but sin v, right? So replace it by that, but it's square ना, तो square है वहाँ पे, तो sin v का square हो गया यहाँ पे, और फिर इसमें u square into cos of v, तो cos of v kept as it is. Here now we'll replace this v here. So v is what? X square. So just replace it by that and get this 30 multiplied by 5 as 150. So 150t into, तो यहाँ पे आएगा साइन, अच्छा इसको ऐसा लिख सकते हैं साइन स्क्वायर v, sin square v, but v is what? V is actually x square. So you have to replace this as x square, and cos of v, again v is x square, so cos of x square as it is. So this is actually going to be the answer in terms of x and t. But if you know that this x is actually going to be 5t, तो जहाँ पे भी x दिखता है तो वहाँ पे 5t डालते जाओ, तो इससे हमको मिलेगा फाइनली 150t इंटू साइन स्क्वायर एक्स स्क्वायर, एक्स के बदले 5t डालेंगे तो यहाँ पे 25t स्क्वायर आ जाएगा इंटू कॉस ऑफ एक्स स्क्वायर, अगेन एक्स के बदले 5t डालेंगे तो वो 25t स्क्वायर आ जाएगा, एंड दैट्स इट. दिस इज गोइंग टू बी द फाइनल आंसर इन टर्म्स ऑफ t. ओके, ये एक्चुअली मैंने जानबूझ के थोड़ा सा डिफिकल्ट लिया क्योंकि इससे तुम्हारे सारे कंसेप्ट क्लियर हो जाएंगे. अगर अभी नहीं समझा है तो एक बार वापस बाद में चल के रिकॉर्डिंग 2-3 बार देखो तो वो क्लियर हो जाएगा आपको. ठीक है, या अगर अभी भी पूछ भी सकते हो अगर कोई स्टेप अगर नहीं समझा तो जरूर. Okay, so this is all about the chain rule. Now we'll move further. The second rule here in the derivative is the parametric differentiation rule. देखो यहाँ पे पैरामेट्रिक डिफरेंशिएशन क्या होता है. ओके, सी पैरामेट्रिक डिफरेंशिएशन का मतलब होता है अगर मान लो एक वेरिएबल है और वो सपोज एक वेरिएबल के ऊपर डिपेंड करता है, ये y जो है तो y डिपेंड्स ऑन t समथिंग, suppose this is t here, and suppose x is another variable here which also depends on t. तो देखो यहाँ पे ये जो y है वो t पे डिपेंड करता है, तो देखो ये suppose there is a connection between y and t, and also that there is a connection between x and t. That means t is the main variable which y as well as x both of these depend upon. तो y और x दोनों जो है वो t के ऊपर डिपेंड करते हैं, ऐसे इक्वेशंस के द्वारा डिपेंड करते हैं सपोज. ठीक है, जैसे ही t चेंज होगा बाय स्मॉल अमाउंट दैट इज डेल्टा t, तो डेल्टा t इस अमाउंट से अगर t चेंज हो गया तो ऑटोमेटिकली क्या होगा, y भी चेंज हो जाएगा, इट विल चेंज बाय डेल्टा y, and at the same time x will also change by delta x. So in that case we can find out the derivative of y with respect to t, which is called as dy by dt. Okay, and also we can find out the derivative of x with respect to t, which is denoted by dx by dt. But in the question suppose we want to find out dy by dx, तो देखो यहाँ पे dy by dx हमको फाइंड करना है, मतलब we have to find out the rate of change of y with respect to x. How will we do that? See here we have dy by dt already, and dx by dt is also already there. ठीक है, dy by dt भी है, dx by dt भी है. So what we have to do is we have to just take the ratio of this dy by dt and dx by dt so as to get dy by dx. Okay, तो dy by dx मिलने के लिए हमको क्या करना है, dy by dt और dx by dt इन दोनों का रेशियो लेना है, जिससे ही हमको dy by dx मिल जाता है. Okay, this is called as parametric rule. Okay, parametric rule. तो जैसे फॉर एग्जांपल देखो suppose x is going to be suppose 3t square. Okay, and suppose y is given to be suppose sin t. Okay, sin t, and now we want to find out dy by dx. Okay, find dy by dx. We want to find out dy by dx. Here we can find out dx by dt just by using this equation. dx by dt कितना होगा, dx by dt it will actually be 3 constant out, and t square का डेरिवेटिव क्या बनता है, 2t बनता है, तो 2t multiplied by 3 comes out to be 6t. no doubt. This is actually dx by dt found out here, right? In the same way, we can find out dy by dt also. So dy by dt, how much it will be? Sin t का derivative क्या बनता है? Cos t. We know already. So now, if we just divide these two, so as to get this dy by dx. So dy by dx can be obtained by dividing dy by dt by dx by dt. So dy by dt upon dx by dt gives dy by dx. तो यहाँ पे dy by dt कितना है? ये देखो cos t है और dx by dt कितना है? ये देखो 6t है. So if you replace them here, then you can get this dy by dx. That's all. So dy by dx is found out to be cos t upon 6t, and that is going to be the final answer. That's all. Okay, this is one of the example of parametric rule. Now we'll see another example here. Yes, suppose we have u expressed as, ये अलग question है अभी. U is going to be sin theta plus cos theta. Okay, and V is actually going to be sin theta minus cos theta. How will you get du by dv? Check. We want to find out du by dv. Okay, हमको निकालना क्या है? यहाँ पे du by dv निकालना है. यहाँ पे हम लिखते क्वेश्चन find du by dv. How can we get that? So first of all, we have to find out du by d theta here. Du by d theta, how much it is? Derivative of this sin theta plus cos theta. What is it? Sin theta का derivative होता है cos theta, और cos theta का derivative बनता है minus sin theta. So here it is minus of sin theta. Okay. What is dv by d theta? Can you find out? dv by d theta मतलब इसका derivative. Sin theta का derivative क्या बनता है? Cos theta again. And what is the derivative of this cos theta here? Is going to be minus sin theta, but minus of minus will become plus, and that's why it will become plus cos theta, sorry, sin theta. Okay, and now if we try to find out the du by dv, then what we have to do here is we have to just take the ratio of dy by d theta and dv by d theta. That's it. So just take the ratio and see what happens. So here du by d theta comes out to be cos theta minus sin theta, right? Yes, and what is the du by dv by d theta? It happens to be actually cos theta plus sin theta. Yes, here it is, cos theta plus sin theta. And this is going to be the final answer. So du by dv in terms of theta will actually be simply cos theta minus sin theta upon cos theta plus sin theta, no doubt. But if you want to express this du by dv in terms of u and v, then we can just find that this cos theta minus sin theta here is same as v here. Check, v तो है ना वो, तो यहाँ पे न्यूमरेटर में जो है वो हम v डाल सकते हैं, नो डाउट. और यहाँ पे डिनोमिनेटर में जो है sin थीटा प्लस cos थीटा, मतलब ही cos थीटा प्लस sin थीटा, वो तो u बन गया, तो उसको हम u लिख सकते हैं आराम से. This is actually going to be the answer in terms of u and v. So du by dv can also be written as u by v, no doubt. So this is another example of this parametric differentiation. Okay, parametric rule का ये दूसरा example हो गया. ठीक है. Let us see the third one. Yes. इसको बोलते हैं implicit rule. देखो यहाँ पे implicit rule क्या बताता है? If suppose we have an equation like x square plus y square is equal to 9, this type of equation is going to be there, suppose. Then we'll see, we want to find out dy by dx in this position. ऐसे हालत में अगर हमको dy by dx निकालना है, how we can do that? तो उसके लिए हमको क्या करना होता है, इस पूरे इक्वेशन को ही डिफरेंशिएट करना होता है with respect to any variable as we want. If we suppose differentiate this with respect to x, then we can get this as d by dx of x square plus, here it is going to be d by dx of y square, which is going to be equal to d by dx of 9 here. So every term has been differentiated with respect to x. So what is the derivative of x square with respect to x? It's going to be 2x. We know that already. Okay. But what is the derivative of y squared with respect to x? What can we say? So derivative of y square with respect to x is actually 2y. Because if you would be differentiating with respect to y here, मतलब यहाँ पे अगर हमने d by dy अगर लिखा रहता इधर, तो फिर यहाँ पे आंसर 2y आता था. लेकिन यहाँ पे ये y जो है, y और ये जो x है वो सेम तो है नहीं, इसलिए हमको इसका चेन रूल यूज करके हमको यहाँ पे dy by dx से उसको मल्टीप्लाई करना पड़ता है, जिसके अंदर x नहीं है. तो अगर दूसरा कोई वेरिएबल अगर आता है y या कोई भी दूसरा वेरिएबल अगर आता है, तो उसको डिफरेंशिएट करने के लिए हम उस वेरिएबल को टेम्पररीली x एज्यूम करके डेरिवेटिव निकाल सकते हैं, बट उसका डेरिवेटिव हमको सेपरेट निकाल के मल्टीप्लाई करना पड़ता है. बस सिंपल सी ये बात है. तो ये हम करेंगे यहाँ पे, एंड दैट इज गोइंग टू बी एक्चुअली 0 बिकॉज 9 इज अ कांस्टेंट. सो कांस्टेंट का डेरिवेटिव हमेशा 0 होता है. And then we can just transfer all the terms containing the dy by dx sign in one side and the terms containing not dy by dx in other side. तो यहाँ पे दो ही terms है, इस term के अंदर dy by dx नहीं है, तो just shift this term in that side so that it will become negative, and keep this term in this side only, so that we can get this 2y into dy by dx is equal to 2x. And then just simplify this further. So 2 cancel and y can be transferred in the denominator so as to get dy by dx is equal to x upon y, and this is the final answer. That is the derivative of y with respect to x. We have found it out. Okay, and as another example, we can see this is, suppose x cube plus y cube is equal to, suppose 4 cube. ओके, ये सपोज एक सिंपल सा एग्जांपल है. ठीक है, अभी इसको हमको सपोज डेरिवेटिव निकालना है. हाउ वी कैन फाइंड इट आउट? डेरिवेटिव ऑफ y विथ रिस्पेक्ट टू x हमको फाइंड आउट करना है. सो वी कैन जस्ट फाइंड इट आउट इजीली. वी कैन जस्ट डिफरेंशिएट दिस विथ रिस्पेक्ट टू x. सो जस्ट अटैच d by dx. तो यहाँ पे आएगा x क्यूब का डेरिवेटिव प्लस यहाँ पे आएगा y क्यूब का डेरिवेटिव, and that is going to be equal to dy dx of this 4 cube also. Don't forget here that this 4 is a constant, right? So 4 cube is going to be a constant. So the derivative of constant is going to be 0, no doubt. But what is the derivative of this x cube here? It is going to be 3x square, remember. Plus, what is the derivative of this y cube here? It's going to be 3y square, but it should be accompanied with dy by dx because y is not same as x here. We are differentiating with respect to x, whereas there is a variable y. So whenever the variables are mismatching, we have to multiply the derivative of that variable with respect to this variable here. Okay. So next step में अभी क्या होगा देखो से, this term is going to be shifted in that side so that it will become negative. So we get this 3y square into dy by dx, which is going to be equal to minus 3x square. अच्छा, ये माइनस साइन यहाँ पे भी आता था ना, ये माइनस साइन रहेगा नहीं इधर. Okay, so just we can cancel this 3 from both sides and get this dy by dx to be simply equal to minus of x square by y square, and that is going to be the final answer. Correct? Eh? So this is called as the implicit rule, but it becomes very difficult when the product of x and y appears in the same question. अगर सपोज किसी क्वेश्चन के अंदर x और y का या किसी उनके पावर्स का प्रोडक्ट अगर आ जाता है, तो ऐसे हालत में ये implicit rule थोड़ा difficult बन जाता है. Just let us try that type of sum also. See here. x square plus xy plus y square is equal to 5. सपोज ये इक्वेशन है और इसमें हमको dy by dx ढूंढ के निकालना है. We have to find out dy by dx. Okay, how can you do that? So see, we have to differentiate this whole equation first with respect to x. So d by dx of x square plus d by dx of xy, okay, plus d by dx of y square as well, and that is going to be actually equal to d by dx of 5 also. Okay, now we'll see this d by dx of x square, how much it is going to be. It's going to be 2x, we know that. Okay, here we'll have to apply the product rule. Product rule of derivatives tells us that d by dx of u into v comes out to be u into derivative of v plus v into derivative of u. That's all. This is called as a product rule. So if you use it here, then we can get this in the bracket. तो इस ब्रैकेट के अंदर इस प्रोडक्ट रूल को हम अप्लाई करेंगे. तो देखो x and y, x can be considered as u and y can be considered as v, so that we can get this x into dy by dx plus y into dx by dx. ओके, ये हमने प्रोडक्ट रूल अप्लाई किया. एंड फाइनली दिस y स्क्वायर का डेरिवेटिव क्या बनता है? It's 2y, and that is multiplied with dy by dx just because y is not x. Okay, so here we can just simplify this further and get 2x plus, here it is x into dy by dx kept as it is, plus here it is y into 1 because dx by dx matlab kya? 1. And finally this is 2y into dy by dx kept as it is again, which is going to be 0. Now we have to keep the terms containing dy by dx in this side only and transfer the remaining terms which don't contain dy by dx here. So ये दोनों terms को हमको उधर भेजना है. तो इसमें से हमको मिलेगा x into dy by dx plus 2y into dy by dx, which is going to be equal to minus 2x minus y. So that in the next step we can take this dy by dx common from these two terms here and get this x plus 2y left inside. Okay, and that is equal to minus sign can be taken common from these two terms here, and we will be left with 2x plus y inside the bracket, so that we can get dy by dx is equal to minus of 2x plus y upon x plus 2y, which is actually going to be the derivative of y with respect to x. Okay, this is called as the implicit rule. Okay, next you can see here in the derivative that it is the higher order derivatives. See here, what do you mean by the higher order derivatives? Higher order derivative मतलब क्या? देखो, suppose we have this dy by dx, okay, and if we differentiate this dy by dx once again, तो dy by dx को भी हमको differentiate करना है फिर से एक बार, तो उसको हम बोलते हैं, इसको बोलते हैं d2y by dx2. Remember, d2y by dx2 का मतलब क्या? Double derivative. Okay, for example, if we have y is equal to suppose log x, okay, then what is dy by dx? Can you find out? Derivative of log x कितना होता है? 1 upon x होता है. We know that already. Now if we just differentiate this dy by dx itself once again with respect to x, then we are going to get the 1 upon x का भी derivative. What is the derivative of 1 upon x? Actually it is going to be minus 1 upon x square. So this is called as the d2x by d2y by dx2. देखो ये d2y by dx2 हमको मिल गया, जो कि minus of 1 upon x square हुआ करता है. याद रखो ठीक से. This is the meaning of double derivative. As an another example, we have y is equal to suppose sin x. Okay, what is derivative of y with respect to x? It's going to be cos x, no doubt. But if you want to find out the derivative of this cos x itself once again. Then we can write it as d by dx of dy by dx actually, and that is going to be minus of sin x here. And hence we can say that this d2y by dx2 is going to be minus of sin x. So this is the example of double derivative here in this way. Even we can also find out triple derivative. If we just differentiate this d2y by dx2 with respect to x once again, then we can get this minus sin x. What is the derivative of minus sin x? It is going to be minus of cos x. So here this d by dx of d2y by dx2 is actually called as d3y by dx3, which can be noted as minus of cos x. That's all. So in this way we can find out the higher order derivatives. तो डेरिवेटिव का डेरिवेटिव, फिर से डेरिवेटिव का डेरिवेटिव, मतलब ही हायर ऑर्डर डेरिवेटिव. So basically the second order derivative d2y by dx2 is called as second order derivative because it contains order 2. क्योंकि हमने दो बार डेरिवेटिव निकाला ना, इसलिए उसको हम बोलते हैं second order derivative. If you differentiate this d2y by dx2 once again, then we get this d3y by dx3, which is called as the third order derivative. Okay, third order derivatives को बोलते हैं. Mathematics से this is all about the higher order derivatives. Okay. Yes, one more thing is remaining here is the inverse function का derivative. See here, if suppose we have y as a function of x, suppose हमको ये y है और ये x है, and somehow suppose y depends on x. ऐसा suppose y और x के बीच में कुछ relationship है जिसके कारण x के ऊपर y डिपेंड करता है. ठीक है. As soon as x will change, y will also change, and we can find out the rate of change of y with respect to x. It is called as dy by dx. But sometimes we are interested in finding the rate of change of x with respect to y, which is called as dx by dy. And the simple thing what we can do here is simply we have to take the reciprocal of dy by dx, which is found out already, and that is going to be the rate of change of x with respect to y. This is called as the inverse rule in the derivatives. Remember, what does it tells us? Rate of change of x with respect to y is actually reciprocal of the rate of change of y with respect to x. Simply, for example, if we have that y is equal to x square, okay, then we can find out dy by dx to be 2x, no doubt. But if you want to find out dx by dy in the same settings, so if you want dx by dy, how much it will be? It will be 1 upon 2x. That's all. Simply you have to reciprocal this. 2x का हमको 1 upon करना है. इससे हमको dx by dy मिल जाता है. That is going to be the simply inverse rule we can say about. Okay, the second example is suppose y is suppose equal to 3 times of x square plus 5x. Okay, ये हमको मिला हुआ है. ठीक है. अभी अगर हम suppose इसका डेरिवेटिव निकालने जाते हैं तो dy by dx अगर निकालते हैं तो कितना मिलेगा हमको? देखो 3 is a constant out, x square का डेरिवेटिव 2x and plus 5 is a constant, again it's out, and derivative of x is 1. So we are going to get that dy by dx is actually going to be 6x plus 5. Okay, you have got the derivative of y with respect to x. But if you want to find out dx by dy in this case, then we can just take the reciprocal of this and get this 6x plus 5 as a final, and that is actually going to be the derivative of x with respect to y, and that's all. So this is actually going to be the rules of derivative. So just revise all these rules carefully. I know that it will be somewhat heavy to digest in the first lecture only, but practice will make all these rules digestive. So basically, you will have to practice all these rules, and I will recommend you that see this lecture at least twice. ठीक है, ये लेक्चर जो आज हमने किया वो एटलीस्ट 2 बार आप देखो. अभी कल छुट्टी भी है संडे का, तो आपको ये लेक्चर जो है वो 2 बार, कम से कम 2 बार देखना है, ताकि इस लेक्चर के अंदर जो भी कंसेप्ट हमने सामने रखे हैं वो आपके लिए यूजफुल हो जाए. एक्चुअली इसमें ये बात भी है कि ये सभी जो कंसेप्ट हम यहाँ पे डेवलप किए हैं, तो ये सब कंसेप्ट आपको 12th स्टैंडर्ड में डेरिवेटिव नाम के चैप्टर के अंदर बहुत ज्यादा डिटेल के अंदर डिस्कस करने हैं, बिल्कुल, नो डाउट. बट अभी जबकि यहाँ पे हमको एज अ एप्लीकेशन ऑफ मैथमेटिक्स टू द फिजिक्स, तो ये चैप्टर का जो मेन मोटिव ही यही है कि इसके अंदर हम सारे मैथमेटिक्स के जो एप्लीकेशंस है, फिजिक्स के अंदर मैथमेटिक्स किस तरह से यूज होता है, वो सब चीजें हम इस चैप्टर के अंदर यहाँ पे देखने वाले हैं. तो इसलिए एज अ फर्स्ट व्यू, मतलब फर्स्ट व्यू में या फर्स्ट सिटिंग में आपको ये थोड़ा सा लेक्चर जो है वो डाइजेस्ट करने के लिए जरूर डिफिकल्ट होगा. ठीक है ना, डाइजेस्ट होने के लिए थोड़ा सा डिफिकल्टी होगा, नो डाउट, क्योंकि इसके अंदर बहुत सारे जो कंसेप्ट्स, जो मैथमेटिक्स के जो कंसेप्ट्स है वो हमने डिस्कस किए हैं, और वो थोड़ा सा आपको हेवी लगेगा, नो डाउट. बट जस्ट प्रैक्टिस and so try to solve large number of examples based on this. So in the next lecture we'll do that. Okay, so we'll stop here. Okay, अच्छा, अगर किसी को कुछ पूछना है तो पूछ सकते हो. Okay, so let us stop here. Thank you all of you.